Hello, I think the network is okay. And first of all, I want to thanks Arsh. Like he posted my YouTube channels and his Telegram channel. And this is like frankly, I'm saying that I was doing this for myself only, just to make mark my words. But I think he noticed my channel and like posted on his channel. Okay, so from now onwards, I will be like solving the problems in a way I am attempting in an interview. Just like I am explaining the interviewer what I am thinking and. It may happen that you cannot understand like most out of the video, but let it be what we can do. Okay, if any cool suggestions are there, please let me know in the comments if anyone of you are watching a video. Okay, so we continue our journey. We were at okay, we have solved the 11th one. Now the 12th one. I think this one I've solved recently. String hashing question it is, Hmm. Okay, now testing hashing was KMP. Yeah, I've solved on October 6th. Okay, so I will okay, so like better to rewrite the whole code. I will just explain it, and side by side I will also revise because I wrote it many time ago, some time ago. Sorry. Okay, so a string is called a happy string if it is non-empty prefix, which is also a suffix. Okay, given a string written the longest. Okay, we need to find a string such that like the longest prefix that is also a suffix. That is basically the like question, and this is nothing but like very naive implementation of KMP. So what KMP does is like it creates a array, let's say to be pi. Okay, pi of I will contains the longest substring that is, okay, longest prefix that is also a suffix of the substring that ends at I character. For example, pi of 2 will contain the longest prefix that is also a suffix in the string lev. Similarly, pi of 3 will contain the same thing in leve. Okay, so the first element is of noise because like if the length of the string is 1, then it is also a prefix or suffix. But we start from like the first position 0 base, so it means a string of length 2. So we will initialize our j with pi of I minus 1, and we will iterate until our j is greater than 0, and si is not equal to sj. We will like move backwards, and in case like we move to any particular j, and if si and sa is equal, we will increment over j and save that in pi of I, and we will return simply pi from the KMP function. And here we take this in LPS array. Okay, now we will return the substring that starts at position 0 and ends at the position of LPS of length minus 1, like that is the length of longest possible prefix that is also a suffix. That is basically needed in the question. Let's run it. Okay, now we will submit it and side by side posting it on GitHub. Okay, so we repeated only 50% of submission. Let's see what others are doing. Okay, yeah, they are getting the same LPS array. Okay, so they are not calling another function, instead they are doing the same thing. Okay, but our solution is also perfect. It's the time complexity is linear only because this function is linear. Actually I can't prove it right now like how it is linear, but there is a very special blog on CPU algorithms which proves that this is linear time complexity. Yeah, this one. Second optimization, implementation, applications. Here we have the asymptotic analysis. Okay, yeah, like the n plus m time basically this was the application when we need to find a pattern, but this function runs in order n time, that's for sure. Let me read that block. I think every question on CP algorithms is sorry, not question, every blog on CP algorithm is very much useful. Okay, so the 12th question, oh, the 12th point. Okay, I saw someone on Twitter had said that this question was very interesting. Let's see if I've done this in past. No, I haven't done this in past. Okay, let's see. Okay, anyhow the question is very much disliked as I can see, but as Arthur mentioned, as this has been asked in online assessment for February 2022. Okay, yeah, it's 2023. N passenger board in an airplane with exactly n seats. Okay, first passenger lost the ticket and picks a seat randomly, but after that rest of the passenger will take their own seat if it is still available, and other seat randomly when they find seat occupied. Okay. Mm-hmm. It's basically a probability question, I think. Yeah, so like if n passengers and n seats. Okay, so when first passenger will like he lost the ticket, so he will like pick a seat with the probability 1 by n. Okay, and now the second person comes. The probability that his seat has already been occupied is 1 by n. Okay, so and otherwise 1 minus 1 by n. Okay, let me think of some formula in my notebook. Sorry for you guys, you can't see it. I think I should buy a writing pad but that's very much costly. Okay, so we had n seats and n people. First person came and picked a seat with a probability of 1 by n. In return, the nth person get his own seat. Okay, the probability for second person getting his own seat is 1 minus 1 by n, and similarly for the third one, if we can find for the third one, we can find for nth one also. Okay, the second person came and found that like possibility 1 p1, his seat has been occupied, so he will select like one of the available n minus 1 seat with probability 1 upon 1 minus n minus 1. Possibility 2, his seat has not been occupied. Yeah, so the probability of that will be 1 minus 1 by n. I'm getting somewhere wrong. Okay, so when like ith person came, he increases the probability that the ith seat will be occupied by 1 minus n minus I. Okay, that's the logic, I guess. And Okay, let's try to guide on it. So we increase some like that's for n. Okay, summation of from I equal to 0 to n of 1 upon n minus I. Let's say, so for 2 what we will have 1 by 2 plus 1 by 1, but that will exceed na. So I equal 0 to n minus 1, say n minus 2 should be so 1 by n plus 1 by n into 1 by, not 1 by n into, it will be simply plus, I guess, by n minus 1 plus 1 by n minus 2, so 1 by n plus what will be the answer for 3. Let's see. Let's say written 0 from here. For 3 they are saying the answer is for 3 also they are saying the answer is 0.5. Okay, and what about for 4? Why it is not clicking? Still they are saying 0. Okay, let's say, I think I've got a logic. I think the answer will be 0.5 always. Let's see for 10. Yeah, so we can simply represent 0.5, I guess. Let's try to submit it. We've got okay, got it where I got wrong. Most people have got this condition wrong. If only one function is there, so but this test case should run first now. But I didn't like the question. Okay, so but even though we have written 0.5, but let's see how it works. Let's see in the solution section. I can't come up with a valid proof. One upon n plus n minus 2 upon n into f1 minus n. Okay, the first person fixed it on sheet. Last one sheet. Okay, when n is greater than 2, fn equal to 1 by n into f of n minus 1 plus. Okay, yeah, that's for sure. F of n minus 1 equal to 1 of, yeah, that is because the second equation requires n minus 1 is greater than 1, so that n into fn means multiply. Okay, yeah, equal to f of n minus 1. Yeah, till that. Okay, n minus 1 into f of n minus 1. Okay, Subtracting both sides will get us okay, n into fn into n into f of n minus 1 is it 2. Okay, okay, yeah, I got it, but it's definitely not a good question, that's for sure. Even though I don't want to post it on my GitHub, but what to do. I don't know the guy who liked this question very much, so he gave this as an online assessment. I don't know why, just to trick the people or so. Stream ongoing now, ongoing, but it's showing some red blinkers. Okay, in between the connection is getting very poor. Usually there's some construction going on in my hostel, so the line connection has been like revoked, and we have been given some Wi-Fi routers which are not very well good, and now I am okay, using my mobile internet. I think I solved this question, no? Yeah, it's on 17th July. Okay, just remove this. If you are given two positive arrays, okay, you can delete any number of elements from nums. Okay, return the minimum number of deletions such that the smallest element in nums divides all elements of nums divide. Okay, that's okay. So we cannot remove any elements from nums divide. We can only remove is just the smallest element. We can only remove these things. Okay, so the n square approach is very simple. Like we first sort the array and then iterate. Let's say if 2 divides all these, and then 3 divides all these, and then 4 divides all these, like that. But how to do it efficiently? Okay, so what will be the highest common factor of the in computer terms GCD of these? Greatest common division, that will be 3, and in this case 16, not 16, 2, but 2 is not present. I think that's pretty much GCD game only. Okay, so we need to find the smallest number that divides the GCD of this. Okay, got it. This is the GCD function a and b. If b is 0, we can return 1. Okay, sorry, a. Otherwise, we can return GCD of b and a mod b. This will compute the GCD in log n time, and we can compute the GCD of a whole array in worst case of log n log n. Okay, you can say, yeah, 32 n considering the numbers, but that's not like valid asymptotic analysis. Okay, so G equal to GCD of B and AI, sorry, BI. Now we can sort the array and then compute. If G mod AI is equal to 0, you can return I plus 1. Yeah. Okay, for case 1, not I plus 1, it will be I only, because we need to remove the left element, not this one. Okay, we have beaten only 52% of the summations. Why? And we calculating GCT is fast enough. Okay, let's see what others are doing. They are also sorting, they are also finding GCD. Okay, just they are using one optimization in GCD. That's all. Let's try to do it. Otherwise leave it. It's unlogging only. That optimization is good, but that do not produce a clean code. Like it's hard to remember. Even though it is fast sometimes, but not like by a hefty margin. Okay, so next question is okay, last one. Okay, but we have one more question that we have left. I think the fifth one. Okay, this one I think also May. Let's throw it. Why did okay? Given an integer s, return the number of such string containing at least one occurrence of all these characters. Okay. Okay, so I think we can consider the shortest possible substring, like we will iterate from that to that, and considering the shortest substring that contains all ABC, and we will expand this by how much we can. Okay, let's say this consists of BCA, okay, ABCs, whatever. So we will consider this BCA, BCAB, BCABC. Okay. Similarly, okay. So right side only we need to consider because the left side will be already be covered. Okay. Okay. Let's say a character set, though it will use only three characters to insert. Let's say count is 0. Or let's use a while loop int I equal to 0. Or low high we can take low equal to 0, high equal to 0. While high is less than n, we will add a high, and also we will increase the high if it is the size is equal to 3. Okay. Then we will be doing while low is less than high, or let's say high minus 2, and That is just size equal to 3. Let's see, we have this thing. Okay, so how many substring possible? I, okay, so high plus 1, high plus 2, high plus 3, 4, and the length of string was 6 here. 6 minus 2, yeah, n minus I. Also we will adjust that. I think we need to consider a map because frequency we need. Bs of I. If let's say hm dot cut of s of low equal to 0, equal to inheritance account. Will be put, it will be m will be or default. We are getting 6. Okay, so this thing A B C. High minus 2, what will be high minus 2? It will be small only. Okay. Okay, so it's a correct answer, but we have hit only 32%. Let's see what I've done last time. Low, high. Okay, I've created same thing like last time. I've created a count array. I mean the same logic. The others are doing. Let's see what these people have done at 8 milliseconds on same frequency thing. Okay, so has been considered to be slower than the frequency array. Yeah, this time I got a 9 milliseconds. Okay, yeah, but this was seemed to be more intuitive, and maintaining or explaining the frequency thing is quite difficult. Not difficult, but harder to explain, I would say. So I think by this all the problems of Microsoft series have been completed, except the one that I've left, that largest divisible subset. Okay, so frankly saying, I visited the solution once and didn't get what the solution was saying. So in the next stream, I think I'll try to solve it. So let's do it now only. We'll wait for another one. Okay, we'll return the largest one.
Every pair satisfies the divisibility property. How we can satisfy that? Hmm. Okay, so let's say if A divides B, okay now, and B divides C, then we can be sure that A must divide C because A is a factor of B and B is a factor of C. So it implies that A is a factor of C also. Similarly, we can build something. What are the constraints? Thousands also, no? 1, 2, 3. Okay.
Because we can do something in LIS thing, but we need to return it also, not only the size. I think let's copy the last time code. That was something similar, no? How many test cases have been passed? Okay, not shown here. We have sorted. Like sorting doesn't create any issue here because we don't need. Okay, do we need the order also? I don't think. Okay, let's try to return. Let's see. Let's comment this out. This dot add 2. This dot add 1. Let's see why the first that fetched. Yeah, 2 1 also passing. So order doesn't matter, you can say. So we were sorting it, and okay. Let's remove this. This thing was something wrong. This also was something wrong. We'll store for till a of I. What was the largest thing that we had? Like at any instance, we will have. Not more than some n minus 1. Yeah, even if we had all the list as all the position, we can fit in the constants easily. Let's do that thing only. Let's keep this to be ours. Okay. Now we will iterate from also add. I think we should add the ith element in this.
Okay, so we need to find if the maximum element divides, so we are sorting. Let it be. Okay, so till 0th position the answer will be the first element only. Okay, for int j equal to 0, so j equal to I. If ai divided by aj is equal to 0 and end list dot get. Okay, so one of my friends from other hostel have called to inquire that if internet is working. Okay, so we were here, so we will list dot temporary list add age not to be j and let's say to a new array list. We will add age ai also, and we will set this thing list dot set at I new array list temp. And also we will maintain a max thing and max equal to 0 and equal to -1. If if list dot get of I size is greater than max, then max will be list dot get I size and end will be not -1 I, and we will return list dot get I end. Let's see if it works. Size here. Need to increment j only. In both cases we got a wrong answer at year 148. What should have happened in this case? Like for I equal to 1, if 2 divides 1 and then like 0, there would be 1. Okay, so at every step let's try to print a list. Here, okay, I need to add a 0. Okay. Yeah, now we will return it. -1, only 2 cases. Why -1? And which line? Here. Okay, let's now switch to 0 only. Now I think it would work fine. Yeah. Try to submit it. 53 cases passed. Moving this
this to custom input. Try running. Oh, okay, sorry, running. Like 3, 4, 8, 16. So firstly 3. They're at second position. Okay, nothing.